So hi, actually this is our core Java course content. So entire core Java course content I have shared to everyone whoever have joined for the class in the last session. So now I am showing it to you. So approximately it may take 56 hours, 56 hours in the sense not more than 2.5 months. I'll take 2 to 2.5 months for completing this course. So generally these are the topics to be covered. First of all, before going to enter into the Java language, before going to discuss about the Java language, I'll tell you some basic terminologies. So first of all, and later we will discuss about Java versus other languages, because Java came into existence in 1991 onwards. Okay, but earlier, before 1991, we have powerful programming languages like C language and C++. So, but because of some drawbacks in C and C++, the scientists, we moved to Java programming language. So, what are those drawbacks and how Java overcome the drawbacks of C and C++? Uh, all those things we will discuss. Okay, once this course content explanation done. So next we are going to focus on Java flavors. Actually, we have three flavors: Java SC, Java EE, and Java ME. SC Standard Edition. That is what we are going to discuss in our course, core Java course. Java EE comes under Advanced Java, and coming to Java ME, it's a mobile edition like Android. So here in our Java course, so we are going to cover entire Java Standard Edition, Java SC. Okay, and here in the types of applications, we can develop different types of applications by using Java language, like web applications, enterprise, distributed applications, standalone applications, like the different type of applications we'll discuss. Each and everything we'll explain it. History and features. Features, or we can call it as buzzwords, means why Java is more popular. Okay, some important characteristics or features will be there for Java, right? Those we will discuss here, and I will show you how to install Java. Okay, and how to install Edit Plus and Eclipse too. And the very first thing you should know before going to start Java basics is JDK, JRE, JVM. Okay, you need to know very clearly about this JDK, Java Development Kit, JRE, Java Runtime Environment, and JVM, Java Virtual Machine. So we are going to focus more on these things because these are very important in the interviews, interview point of view. So you may get see, even though experienced guys also will get questions on these particular topics, right? And further we'll enter into the Java basics. Okay, like keywords, identifiers. For writing a simple Java program, we need to know about all these things like tokens, literals, variables, data types, constants, operators, like this. These are all the basic things we need to know before going to write the Java program. And here we are focusing on structure and simple Java program. And there are so many ways to give input to the program in Java. Generally in the C language, you'll be using a scanf function, and in C++ you'll be using cin, right? So here in Java we have so many input methods available. Each and every method with examples, we'll discuss it very clearly. And the next one is coming to that. The next topic is flow control statements. Okay, so loops, okay, and branching statements, decision making statements for each loop, transfer statements, like all these things will be covered. Followed that, arrays, a very important topic, arrays concept, because when you have a very good idea on arrays, you can easily understand the collections concept. Collections is nothing but a data structures. See, in C language and C++, we have data structures, right? The same thing here, we will be calling it as collections. Okay, but if you want if you want to know very clearly about collections, right, compulsory you should have good knowledge on arrays. That entire thing with examples, not more than, for entire course, right, we will be covering not less than some 500 programs approximately. And once that arrays concept gets completed, we are going to start object-oriented programming concepts. Here, class will have 5 important elements like variables, methods, constructors, then static blocks, instance blocks. Okay, so these are all very important topics in the interviews: access modifiers, encapsulation, inheritance, polymorphism, abstraction. I have briefly explained the what syllabus right here, but so many subtopics will be there under this: polymorphism and types. Okay, so runtime polymorphism, static polymorphism, like this, so many types. Abstraction, coming to the abstraction, we have abstract classes and abstract methods. Okay, and the very important topic is interfaces, right? So inner classes, API documentation creation, how to create an API documentation. Generally, the Javas of people, I mean, who developed Java, that guys, I'm calling it as Java soft people. So they only provided the documentation for Java, but when we are using Java for developing the projects, so see, for your project also you will be developing the documentation, right? How to create a documentation using Java for our project, that I will show it to you. And jar file creation, generally in your generally in your daily schedule, right? Real time will be sharing all the files as a jar file only, right? So how to create the jar file, what exactly the jar file contains, everything will explain. And the very important topic in interviews is strings, string buffer, string builder classes, wrapper classes, reflection API, regular expressions. Under this exception handling mechanism, here I have mentioned the days. You have to see here 38, 39. See, minimum it may take, I have mentioned 2 days, but minimum based on the doubts. And see, if we take more and more examples, obviously it may take another 1 or 2 days extra too. I have mentioned like that, but still 56 days in a sense, I'll take another 20 days, compulsory 20 to 30 days extra, minimum 2.5 to 3 months it may take to cover all these concepts, right? So one of the very important concept in core Java is collections framework, multi-threading, right? And here AWT, swings, applets, okay, for developing the GUI applications. So this also, no one is using all this because now CSS, HTML is there, right? So everyone is using all those, but still we'll discuss about these topics because sometimes some old projects will use us all these. For that purpose, I am going to discuss all these things too. And here Java new features. By the time it's 1.9, but now it's 1.13, right? But still here 1.10, 1.11 features also will add. Java new features too will discuss. Okay, this is what our entire core Java syllabus that I am going to cover in our entire course. Okay, understood? And coming to our topic today. Yeah. So coming to our topic today. So today I'm focusing on why we are using Java, what are the drawbacks of C and C++ languages. That I'll cover it for this demo session. First of all, what is platform? Platform is nothing but what? It's a software and hardware environment, combination of software and hardware environment, where you can run your applications or programs, right? If you want to run your applications or programs, compulsory you need a software and hardware environment, right? So that we are calling it as a platform. Actually, we have two types of platforms available: platform dependent and platform independent. So coming to the platform dependent, so if what is mean by platform dependent? If an application, you have developed one application, okay, and if that application run in one operating system and it cannot execute it in another operating system, then that is known as platform dependent application. If an application run in one OS and it's unable to execute in another OS, then it is known as platform dependent applications. So this, if you want to develop this type of platform dependent applications, you're going to use C language, VB, all these things you will be using. But nowadays everything is based on internet. So most of the time, most of the applications are platform independent only. So it's not possible to develop platform dependent applications, right? So what is mean by platform independent? If an application run in one OS, able to run in another OS also, then we'll be calling it as platform independent application. Okay. So to develop this type of platform independent applications, we are going to use Java, Python, all these. Understood? So this is nothing but platform dependent and platform independent. So what is platform dependent? If an application run in one OS, unable to run in another OS, that is known as platform dependent application. If an application run in one OS, able to run in any OS, then it is known as platform independent application. So to develop this type of platform independent applications, we are going to use this Java and Python. Okay, coming to our Java history. Very simple. In 1990, Sun Microsystems, so they got one project. Actually, the project main intention is to control consumer electronic devices with remote. Actually, see set-up boxes, like ovens, like these things now. So by that time we don't have any remotes, right? So to control these electronic devices with remote, that is a project the Sun Microsystems got by the time when in 1990s. So they named this Sun Microsystems now, they got this project, right? So they named that project as a stealth project of Green project. By the time James Gosling was working as a project manager in Sun Microsystems. So he got that project, this project. So what James Gosling thought first, okay, see from 1972 onwards we have C language, 1980s onwards we have C++. Got it? So in 1990, Sun Microsystems got this project. By that time, he was working as a project manager there. So he is going to handle that project, James Gosling. So the founder of Java. Okay. So he was called as the father of Java programming language because he only developed Java language, James Gosling. So first of all, James Gosling thought of to develop this project using C and C++. Okay, so and later he decided that no, C and C++ have some drawbacks, some problems, so it's not possible. If we develop this project using C and C++, the project will also suffer with same problems. So that's why he decided that okay, we'll develop a new language which will overcome the problems of C and C++. So that's why James Gosling, what he did, he initially named, first of all, before going to develop that project, he decided to develop a new language which will overcome the problems of C and C++. So initially he named that new language as Walker. So from 1991 to till 1995 they developed. Who? James Gosling with his team. With his team means Patrick Norton, Bill Joy, Ed Frank, Chris Roth, Mike Sheridan, like that. So many people are there. Everyone's contribution is there for developing the Java language. Not only James Gosling, everyone in his team members, see their contribution is there for developing that the most powerful programming language called as Java. Right? So from 1991 to 1995, they developed this language. In 1995, Alpha Beta version released Java, and along with that, they developed one web browser too, Hot Java. So officially in 1996, the first version of Java, JDK 1.0, released in January 23rd. Okay, the first version of Java, JDK 1.0, released on January 23rd. Got it? So this is what a brief history of Java. Who was called as the father of Java programming language means James Gosling. So now I explained, right? They initially named as Oak, and later because Oak name is already registered by some other company has already taken the copyright issues for that name. So they renamed that new language as Java in 1995. But Java is one island name where the first coffee beans, that has developed, has grown there. That's one island, Java Island in Indonesia. So this is what the history of Java. Okay. Now, before going to start Java, I'll explain what are the problems, what are the drawbacks of C and C++. Coming to C drawbacks, first of all. Platform dependent. Yes, of course. I said no already. If you develop an application using C, that is going to execute only in one system, cannot be executed in other systems. It's not possible. Got it? Because executable file code .exe file will be formed now, so it will not be executed in other systems. Compatibility problems arises. So the first drawback of C is platform dependent. C is most powerful language. The very powerful Unix operating system is written in C only. Of course, most of the system softwares will also be written using C language only. For system level programming purpose, C is very popular even now too. Got it? So of course it will have some advantages, but by using C we cannot develop platform independent applications. That is the first drawback. Second drawback is recompilation. So when you develop a C program, so every time, I mean, if you want to execute that application or program, compulsory, if you want to execute it for 5 times, compulsory you have to recompile it. Every time if you want to execute, you have to recompile, and then only it will get executed. Recompilation is a very big problem here. And the third one is pointers. Of course, pointers is a very, very important topic in C language. Pointers plays a vital role. Got it? Because pointers are used for storing the addresses. But see, if you want to access any data through addresses, you are going to use these pointers only. But still, it leads to confusion for the programmer. So some dangling pointer problems, like that. So many problems arises, and the complexity of the code will also be increased. See, pointers is not data structures. Using pointers means it's not a small thing, right? So complexity will be there. That's the third problem. And it is architecture dependent. Even see, if you execute one program in one system, the architecture depends on the architecture. Got it? So it will not be executed in other systems. And some security issues will also be there. Not that much security is not there for C. Virus attacks will also be there for that. So because of all these drawbacks, the main important drawback is pointers, recompilation, and platform dependent, first of all. Got it? So by using C, you can develop system softwares and platform dependent application softwares, but you cannot develop platform independent applications. That is not possible. That's why we shifted to C++. It is an extension to C, you know that. So in the earlier days, 1980s, early 1980s, C++ developed by Zarnes Stroustrup. So actually, this C++ was developed based on C only. So earlier they called it as C with classes, but later they renamed it as C++. So C++ is nothing but entire C plus object-oriented programming concepts is nothing but C++. Next, in the further classes, I will discuss about this object-oriented programming concepts. These are very, very important. If you understand these concepts in Java clearly, then anywhere you can understand. It's not. It will become easy. So, classes, objects, encapsulation, abstraction, inheritance, polymorphism. These are all known as OOPS concepts. So, of course, OOPS concepts plus C is combination is nothing but C++. But C++ will also have some problems. Here also, because it is an extension to C, no? Here also we have recompilation problem. Here also we have pointers problem. And actually, it is not a pure object-oriented programming language. It fails encapsulation concept. What is encapsulation? Actually, in the C++, you can write a program with using classes without using classes. Got it? Let me explain. Say example, I want to add two numbers, something, any program. In C++, you can write a program like this directly. Like this. And you can write a program like this too. Like this. Some code I'll write it here. Okay. That means in C++ you can write a program with using class and without using class too. Encapsulation means providing security. So wrapping up of data and functions together and put it in a single place is known as encapsulation. I will explain very clearly about these OOPS concepts in the further classes. Okay. So let me explain this briefly. Encapsulation means providing security for our data. How will you provide security for your data? By using class. When we declare variables and functions inside a class, this class will provide security for our data. Simple example I will tell you. Take one capsule. Inside the capsule, we have some medicine, right? Some pinch of medicine is there, no? Why they have filled that medicine, I mean pinch of powder or medicine inside that capsule? That wrapper protects that particular medicine without losing the power, isn't it or not? The same thing here too. This class is protecting our data. Inside this class, whatever the variables functions you'll write, this class is going to provide security. Got it clear? But in C++, you can write a program with using class and without using class too. That's why it is not a pure object-oriented programming language. It fails encapsulation concept. And here also recompilation problem is there. Here also pointers problem is there. Because of all these drawbacks in C and C++, we shifted to Java. That's why James Gosling decided that not to develop that project. See, no, Sun Microsystems got one project now to develop, to control consumer electronic devices with remote. That's why he thought of to develop a new language which will overcome the problems of all this. That's why James Gosling developed this Java. Okay. Now, what are Java advantages? Let me explain. Platform independent. Of course, when you write a program or when you develop an application using Java, it will be executed in any OS. So if an application runs in one OS, it will be executed in another system too. That is nothing but platform independent application. Got it? And one more important thing is no recompilation. Here, once you compile a Java program, no need to recompile it. Once you compile, that's enough. Ora or Cora. Write once, run anywhere. Compile once, run anywhere. Once you compile, you can run it anywhere, anytime, any number of times. That I will explain you very clearly using diagram now. Okay. Next, scientists totally avoided this pointers concept in Java. No pointers in Java. No pointers in Java. Full security. In the internet also, full security is there. Okay, because so many algorithms it will follow. Okay, digital signatures and everything. Architecture neutral. It is neutral on the architecture, neither dependent nor independent. No virus attacks, and it's purely object-oriented programming language. Why? Because without a class, you cannot write a Java program. Without a class, you cannot write a Java program at all. Compulsory, if you want to write a Java program, at least one class should be there in that program. Otherwise, you can't write it. That's the thing. Got it? So these are the advantages of Java, which has, see there, those are platform dependent, but here Java is platform independent. Recompilation is the problem there, but here no recompilation. Write once, run anywhere. And their pointers is a very big problem, okay, which leads to complexity of the program, but here no pointers at all. Full security. Architecture dependent there, but here it is architecture neutral and purely object oriented. Got it? Compulsory, you need to write a class. If you want to write a Java program, it should contain at least one class. Okay? So these are the Java advantages. Let me explain these advantages using diagram. See, this is Java compilation and execution process. Okay, I have written one program known as demo.java. Generally, demo is a primary name and .java is the extension name or secondary name. See, this primary name is used to identify the file and secondary name or extension name is used to identify the type of a file. Got it? So whatever the code you will write, that we are calling it as a source code. Let me take one example. I have written one program. I'm going to write one program for Java. Public static void main. Okay. Here I'm going to write system.out.println. I'm just writing. Next I will explain. I said no in the last session itself. I'll explain it very clearly. Simple Java program. Okay. So like this I have written one program. This is a Java program. I saved this program as what? Demo.java. Okay. This is what our program, Java program. Coming to our diagram. When you write the code, this is known as, these are what? High level instructions, no? This is known as what? Source code. Got it? So demo.java contains what? Source code, or we can call it as a high level instructions. What happens exactly? What is the Java compilation and execution process? When you write a Java program, when you compile and execute, internally what happens? That's what our diagram. Java C. Java C means Java compiler. Okay. This Java compiler will take this demo.java. I mean, will take the source code, high level instructions, converts that high level instructions to bytecode instructions. Demo.class. Converts, Java compiler will convert this .java file to .class file. .class file contains what? Demo.class. Okay. What this .class file contains? Bytecode instructions. What is bytecode? Is bytecode and object code same? Object code means what? Zeros and ones. You know, in the C language, when you compile, you will be getting object code, na? Zeros and ones code. Generally, system understands that code only, right? So, is this bytecode and object code same? No. Bytecode is different. Object code is different. So, when you compile Java program using Java compiler Java C, you will get what? .class file. What that .class file contains? Bytecode instructions. What is that bytecode? It is one type of highly optimized virtual code. Got it clear? It is one type of code which is understandable to JVM, Java Virtual Machine. Bytecode is not same as object code. Bytecode is one type of highly optimized code which will be understandable to Java Virtual Machine. Let me show you the bytecode. This is what the bytecode is. The code in zeros and ones? Is that code in zeros and ones? No. This is one type of code which is understandable to JVM. This is nothing but bytecode. I'll explain what is this entire bytecode and everything. Okay, understood my point? So here, coming to our diagram, when you compile Java program, you are getting .class file which contains bytecode instructions. Bytecode instructions are not same as object code. That is different. That object code is nothing but zeros and ones, but this is one type of intermediate code. Bytecode is one type of intermediate code which is understandable to JVM. Why you are calling it as bytecode? Because each and every bytecode instruction occupies 1 byte of memory. Every bytecode instruction occupies 1 byte of memory. That's why we are calling it as a bytecode. Got it clear? So this bytecode instructions is understandable to JVM. Now you will get what is JVM. Java Virtual Machine. Java Virtual Machine. Generally, why JVM is using actually? Okay, let me explain. You have written one C program. Okay, you have compiled, you will get object code. Take this same scenario, same example. In this diagram, we have used Windows OS, Linux, Solaris, Mac OS, like that. No, same way. In the place of this JVM is not there. Only demo.c, demo.obj file is there. Okay. So this, see, when you develop an executable file, see, you have Windows operating system, you have compiled one C program, you have executed, you got the .exe file. Okay. When you can you execute the .exe file in Linux? No. Can you execute that in Solaris? No. In Mac OS? No. That means what? If I have Windows operating system and another person have Linux, another person has Solaris, you will ask, okay, Bindu, you do one thing, you have written some application, right, in C language. Can you send that executable file to us so that we'll execute it in our system? Okay, of course, I'll send it. But what happens? Because mine is Windows and yours is Linux and some others is Solaris, it's not possible. Executable files will be varied from OS to OS. It will not be executed. That's why we are calling it as platform dependent. If you want to execute the application executable file, what I am sending, compulsory your system will also have the same OS, whatever my system contains. Got it? This is what the biggest problem in C language. That's why we shifted to Java. Okay, then what this JVM will do? Let me explain. Understood up to here? After compilation, you got .class file which contains bytecode instructions. Now, every system will have JVM. Every system will have JVM. Every OS will have a JVM. Okay, when you install Java, are you getting JVM? No, no. Every OS will have by default JVM is there. Got it? Windows will have Windows related JVM. Linux OS will have Linux related JVM. Solaris will have that related JVM. And Mac OS will have that related JVM. Java Virtual Machine. Virtual Machine. Now what this JVM will do exactly? First, every OS will have their own JVM, right? That's why I drawn separate JVMs here. Please understood. All JVMs are not same. Every OS will have a JVM, but all JVMs are not same. Windows will have Windows related JVM, Linux will have Linux related JVM, Solaris will have that JVM. Implementation varies here. JVM implementations varies here. Every system will have separate JVM, but all JVMs can understood this bytecode instructions, this .class file, because it was designed like that. Got my point?
Bindu Pravalika. Yeah. So basically, like when you are installing Java itself, like you install it like for whichever is compatible for Windows, if it is your Windows machine. So like that, like you're saying, it'll have separate JVMs. Is that right?
Yeah, compulsory. Java will have a separate Java software is available for Windows 64-bit, 32-bit also, and for Linux also separate Java software is there, no?
Yeah, okay.
So that is what I'm telling. See that Windows, see even for 64 and 32-bit, two separate Java software is there. That executable file will be different, right?
Okay.
So I'll show it to you when I'm installing Java software in my system, right? I'll show it to you. Every OS will have a separate Java software available. It will be varied. So Windows will have that related JVM implementation. This will have that related JVM implementation. That's why I have drawn separate JVMs here. Every OS will have JVM, but all JVMs are not same. But any JVM can understood this .class file, wherever the .class file is. But that .class file contains what? Bytecode instructions. Now, those bytecode instructions are designed like that. That makes the Java platform independent. Got my point? Let me explain. I have Windows. You have Linux, and some others will have Solaris or Mac OS. I have written one Java program. Just now I wrote a hello world program. Demo.java I saved. I compiled. I got the .class file. And you will ask, Bindu, at the end of the session, you shared that .class file to us. You'll ask, okay, I'll send that .class file to all of you guys. Is it executed in your systems? Yes, of course. Why? Because, of course, yours is Linux and some others is Mac and mine is Windows. But still, all systems will have JVMs. All these three JVMs are not same. But every JVM will understand the .class file, what I am sharing it to you guys. That .class file instructions inside that bytecode instructions are designed like that. Got it clear? So I will send a .class file to both of you. What you will do? You will directly copy the .class file into your system. And can you compile it again? No. Already compiled code only I am sending it to you. See, after compilation only I will get this .class file, no? So that .class file only I am sharing it to you guys. So you no need to compile it again. You no need to recompile. Already compiled code I am sending it to you. You will directly, your JVM, in your Linux system you have JVM, na? That JVM can understood this bytecode instructions contained in .class file. That JVM will understood that bytecode instructions which I have shared .class file, right? It will execute, it will convert that bytecode instructions into machine understandable code. Machine understandable code means, you know, zeros and ones, right? But you are not getting another file. You don't get in the C language. Finally, you will get .exe file, C++2. But here you won't get any .exe file. So JVM directly take this .class file, converts that bytecode instructions to your system understandable format, and finally gives the output. It does not generate any other file here. Internally, it will convert. It will do it internally. All the processings will be done internally, and finally you will get the output. So in entire Java compilation and execution process, you have only two files. One is .java file, one is .class file. That's it. Understood?
Yes, Bindu.
Any doubt?
No.
Okay, fine. So here, so these JVMs, what these JVMs, all JVMs are not same, but any JVM can understood bytecode instructions contained in dot class file. So this dot class file is taken by all JVMs contained in all systems. Okay, this JVM will convert the bytecode instructions into machine understandable format, and then finally you are getting the output. This is what Java compilation and execution process. Let me explain how Java overcome C and C++ drawbacks based on this diagram. I will explain now. See here, this is platform independent. We'll agree. Why? Because this demo.class file I have developed in my system. I compiled. I got this .class file. Mine is Windows. Yours is Linux. Some others is Solaris. Some others is Mac OS. But still this demo.class file is understandable by all JVMs in our systems, and it is going to execute it. Finally, you are getting the output. That makes the platform independent. And here, no recompilation. Why? Are you recompiling again? I have sent .class file to you. Are you guys again recompiling? No need, because already compiled code I am sharing it to you. So no need to recompile. Directly you can, your JVM will understand, it will execute, you will get the output. So no question of recompilation. And no pointers at all. Finally it is removed. No pointers at all. Full security. No virus attacks. Neutral on the architecture. Neither dependent nor independent. Got my point? And one more thing is, now I'll ask some questions here. Java software is there, na? Java software, that is dependent. Why? Because just now I said, Pravalika, you only asked. Okay, then Java, see, for Windows, for Linux, for Solaris, for Mac OS, separate Java softwares are there. So when you have separate Java softwares available, that is nothing but that's dependent only, na? So Java software is dependent. Java programs independent. Because when you write Java program in one system, it is going to execute in any system. Java programs are independent. Got it? What about JVM? See, JVM, dependent or independent? Obviously dependent, no?
Dependent.
Because here, see here, Windows will have that separate JVM implementation. This will have separate JVM implementation. So JVM is platform dependent. Java programs platform independent. Software dependent. This .class file independent. .class file is platform independent. Why? Because any JVM can understood .class file bytecode instructions. Understood? These 4 points compulsory you need to remember. Java software dependent, programs independent, .class file independent. Why? Because all JVMs can understood this .class file, na? Bytecode instructions. That's why independent. But JVM, every OS will have separate JVM, na? So dependent. Got it clear? So this is what Java compilation and execution process. But in Java, everything, even main method also, you should write inside class only. Without a class, you cannot write a Java program at all. That's why it is purely object oriented. Without a class, you cannot write Java program up to some versions. Later we have shell scripting also in Java, then you can do it directly. That's different. But generally speaking, you cannot write a Java program without main method. Okay? Understood this one? Any doubts here? May I know who's here? Caller 1. I think your name is not coming. That's why. Hello. Yeah, okay. This is what Java compilation and execution process. Our next topic is JDK.
I think it's me, Venu.
It's you only. Venu, your name is coming, right, Venu?
But from my laptop, the audio is not coming, so that's why I dialed in.
Oh, okay. Okay, Venu.
Yeah.
No problem. So, here the next topic is JDK, JRE. Okay, we have public JRE and private JRE too. Java Standard Library or API. These are the other topics we need to discuss. Okay, so when you install Java software in your system, you are getting two folders. One is JDK folder, another one is JRE folder. JDK means Java Development Kit and JRE means Java Runtime Environment. Okay, that JRE also two types, private JRE, public JRE. This is what? JRE and this is JDK. Got it? So this explanation, so before going to start basics of Java, we need to discuss about this JRE and JDK. And finally, next we'll enter into the actual concepts. Got it?
Yes, Bindu.